So thank you very much, Munir. We seem to have got quite a collection of clinical pharmacologists in this room. We're meant to be a rare breed these days, but we managed to get them all in the room at one time. So I'm going to share with you a little bit about where we are and how we've been thinking about pharmacogenomics, developing some of the concepts that Ellen beautifully outlined earlier in how we've been approaching this in the 100,000 Genomes project. Now, it's probably worth saying in our original mission in the 100,000 Genomes project, pharmacogenomics was not a part of the discussion at that time, but it was obvious to those of us associated with this that this had to be a platform for energizing this and taking the excellent work done by many of you in this room and converting it into a healthcare opportunity for patients. So the 100,000 Genomes is not 100,000 people, it's about 70,000 people, and they have rare disease, cancer and infection. In a moment I'll show you how their genome is helping their treatment. Sometimes that's not with a drug, sometimes it's about something else that's not necessarily something we would regard as a drug, but nonetheless I can give you some examples in both rare disease and cancer of the benefits of the project. And then I'll take you through how we're harnessing the 21 petabytes of data, which will eventually be much more than that, and the 13 genomic medicine centres across the whole of England, and by the way, now, and as a result of last week, Scotland, Northern Ireland, and last week on Wednesday, Wales joined the project, the entire UK. That's about 1,500, but sometimes we think it's more than that, possibly up to 3,000 frontline NHS staff working on the project each week, and we've got a coalition that's now enlarged to 2,700 researchers and colleagues from around the world who've agreed to share their intellect and drive up the value of this data for patient care. So where are we in the project? We have 76,000 samples distributed across cancer and rare disease. Rare disease enrolled a lot more because cancer proved to be quite challenging to get live in the NHS, and we've now got it live and it's working extremely well and delivering fantastic quality genomes. So we now have, and in fact this is being announced today, 50,000 whole genomes in the data centre. The Department of Health will be announcing that today, and that breaks down as you see. And then what we've done is returned 16,000 genomes to 7,700 families and over 1,000 cancer genomes to the NHS. In rare disease, that presents 20 to 25% new diagnoses for patients, but that decision as to whether we've reported a clear diagnosis is made by the NHS. In preliminary data from the first 1,100 families, the NHS confirmed the diagnosis in 23 out of 25% of the patients and fed that back. So now in our research environment we have clinical data on 53,190 patients or participants in the project and 31,384 genomes available for research. This is a very rich data set, so to give you an idea, just the hospital episodes alone as secondary data amounts to 3.6 million data points, and that's in addition to the primary clinical data that we collect with the rare disease and cancer patients. And so this becomes a rich life course resource where we can begin to follow treatment exposures through registries, and we will eventually have primary care data and all the pharmacy data that we can get. So we're committed to establishing a national data repository to allow people to interrogate the genome alongside drug exposure and all the lifetime exposures that we can capture through this real-world data set. And where are we in rare disease? Well, we enroll about 500 people across 1,200 disorders every week across England, and they are standardized, and standardized is the key to this. Ellen mentioned it earlier, but by standardizing things, what we will achieve is an equitable access to care, irrespective of the geography you live in, across the whole of our nation. And Scotland, Northern Ireland and Wales are involved in the working groups for the planning of the NHS service, so they will be connected into this, and I'm sure will join too. So we collect standardized data, we collect their usual genetic testing, and we record every 2 weeks how well they're doing, and the NHS records about 6 terms for the presence of a disease clinical feature and about 20 for the absence of the features. And this allows us to focus our search with a panel app in the genomes, and that helps us achieve the 20 to 25% actionability. So here are the rare disorders by system that we're working on, and you can see that, as you might expect, the majority of those are rare disorders rare neurological disorders, rare intellectual disability, and cardiovascular disorders. So we monitor this for equity of access. We monitor it for equity of access crossed by disease, but also by ethnicity. And I can tell you that the rare disease program, even though the representation of minority communities according to the census is 14%, there are over 25% of the rare disease program reflecting increased burden in certain of our communities. So it is reaching the people it was set up to do. And this is one case here, and the reason I'm showing you this case is because it has changed treatment, but I actually want to use this not really to talk too much about the case, because we've shown this a number of times before, but I want to use it as a framework to show you how complex this information is to handle and what an effort it is to resolve the answer. So the young lady in the middle there had a presentation with developmental delay at 4 months, and then had intractable seizures which responded to no medicine, had previous adnexome, and then had joined a charity and came to know about the 100,000 Genomes project. Through that, we found that she had a glucose transporter 1 mutation, which means she can't get sugar easily into the brain, and therefore this was de novo in her, so her mum and dad don't have it. And this illustrates the familial impact of this, because mum and dad were thinking, would they have another child? And they've now had the opportunity to reconsider that. And a high-fat diet allows the brain to make sugar, and therefore the seizures have reduced somewhat. But I really wanted to show you this, which is about how complex this was. So this young person's genome had 6.4 million variants, of which 677,000 were rare. This filtered down to 2,826 that change a protein, and there were 67 that were different of parents, and one of which was in a gene that has a potential candidacy for this type of epileptic encephalopathy. So that's what the team at Genomics England are doing every day, and they can do this in as short a time as 10 hours in certain cases. So it takes between 10 to 35 hours in our semi-automated pipeline to analyze the genome. Of course, we don't get this type of answer for every patient, and it won't impact their treatment necessarily, but I'll just show you some cases where it has. And this is the serendipity afforded by actually concentrating genomic testing in one environment, so you can start to look for associations with potential drug impact or therapeutic impact that you mightn't see by having this data in silos distributed across a health system. So in this first case, this child had had a 9-year diagnostic odyssey, and as a result of a recessive mutation was found in ERCC8, diagnosis of cocaine syndrome, which is associated with a small head, rapid aging, and intellectual disability, and unfortunately doesn't have a very good prognosis. But there are case reports of at least 8 cases where the exposure to metronidazole has caused hepatic failure and fatality. And this is a warning that's issued now across the world for this particular group of people to avoid, if you can, metronidazole, and if it's imperative to use it, monitor liver function tests. This is an example of a 36-year-old man who has now got his diagnosis of choroidemia, allowing us to actually consider him for a gene therapy trial. So not all of the therapeutic outcomes are necessarily dietary or medicinal. They may be a gene therapy trial. And then finally, a final case is a 10-year-old girl with multiple life-threatening infections, multiple admissions to the intensive care unit, and she has a defect in the CTSP1 gene, which means that she now needs a curative bone marrow transplant, which was not known by her clinical team. So I'm using this to emphasize, even though we're here to talk about pharmacogenomics, that there are a range of therapeutic options that can occur, and even from a genome taken originally from a completely different disorder, you can find hidden hazard in the therapies that people might be exposed to. So as we enlarge and concentrate this national data center for genomics, we will have a unique opportunity to examine drug-gene interactions in a way that will allow us to capture the evidence that we so badly need to make these things into testable features in our health system. But also, even more, because some of these things are really rare but really severe, we may need to look at this in the context of bringing live to test in the NHS the opportunity to do this so we can create the evidence base that will allow us to have a safer use of medicines in our health system. So in cancer, this has been much tougher because the way in which cancer is treated with a preservative called formalin is very damaging to the DNA, and we've had to re-engineer the whole of molecular pathology. We work across a whole host of cancers now, which represent the cancers that the NHS deal with on a day-to-day basis. And we've now got one of the largest cancer resources with whole genome sequencing in the world in a health system. Because we don't always think about this in this way, we just wanted to share with you some data from the first 672 cancer patient reports. And what this suggested is in pink here, you can see potential actionable single nucleotide changes in genes that have a clear druggable target. So I'm not saying necessarily that in 66% of these cases we could choose a drug, but I am saying that there are opportunities that are arising from this. And when we see this information laid out as it is here, what you begin to see is even if that was 20% or 30%, this would be a substantial gain in targeted therapy from this type of activity. Now, I don't know if this will stay the same. This is early data, so it may not. I suspect with time it will reduce. But even if in a few people we could choose the therapy in a more targeted way, this could make some of the expensive therapies that today we struggle to bring live in our health system affordable in a targeted manner. And here's an example in biopsy, which we had to work very hard on to bring live, which is very important in cancer. There were several opportunities from routine healthcare. In the red bars, you can see patients who could have had a medicine chosen potentially on the NHS as a result of the genome. But more importantly than that, because that was very few, there were many cases in green of early phase clinical trials that could be opportunities for the patients, and in blue, later phase trials. So these results do open the door for other opportunities for patients, and I think in our broader approach to pharmacogenomics, we have to consider the value proposition of harnessing this information for patient care. So here's a real example from a family in the program. And this is a lady who had a triple negative breast cancer, often a very aggressive form of disease. And she then had her germline revealed a BRCA2 mutation, and it was also in her somatic genome. And she had a mastectomy, chemotherapy followed by radiotherapy, but enrolled as part of the 100,000 Genomes project. And the finding of that particular mutation allowed her to access a PARP inhibitor that she might not have got access to otherwise through a clinical trial called the Olympia trial. This is olaparib. And there was also, to speak to the point very eloquently made by Heart UK, the opportunity to cascade this out into other family members. So we now know, as a result of this, that her own daughter has a BRCA2 mutation and will receive enhanced breast screening as a result from the age of 30. Equally so, the males in the family, BRCA2 mutations are potential risk factors for prostate cancer. So should they choose to, they can have the opportunity. So these results are not confined to an individual. They have familial impact, and they can help us choose the treatment for the patients and gain access to medicines that the health service might not have deployed under routine care. So we're using the principle of our fundamental feedback process, which has been well tested with our participants and they're enthusiastic about. And actually, as Viv has alluded to, our participants want more information than we would usually think about giving them. So we've really listened to that, and they receive information about their main condition, but they have some additional findings. And these additional findings will be the route by which we will introduce pharmacogenomics into testing in the NHS, by adding pharmacogenomics into this element of the testing pro forma that's offered to patients. So they can receive particular findings that are actionable because they cause other serious conditions, and we will be adding in some pharmacogenomic tests from April 2019. Similarly, so they can find out things about carrier status if they're parents, and they can opt to receive that information. And we will gradually use this to gather the evidence base to allow us to broaden pharmacogenomic testing. Now, of course, this is where many of you come in, because clearly what we need to make this work is a coalition of researchers who will work on the data, and Munir here is leading the Pharmacogenomics section of the Stratified Healthcare and Therapeutic Innovation domain in our Genomics England Clinical Interpretation Partnership. So if you want to know how to get involved in research in this area, talk to Munir. He's our lead on that. And here's the data that's available to the researchers. Only a small number in there at the moment, about 255 to be precise, because we're increasing it gradually so that we can test the data center in the environment. So that's the distribution we have. And we're capturing other data sets. And Munir, as I say here, will be leading the work on pharmacogenomics with many of you, I hope. We do have a big interaction with industry, and there are now over 39 companies that are involved in working with us in different ways, mostly to understand how they can use the data in their business activity for patient benefit and to bring inward investment to the United Kingdom. But just to focus back on the points that Ellen made earlier, and just pick a few of those out. For the first time in England, from October 2018, we will have equity of access to genomic testing, including cascade testing, because that's in the test directory. The test directory is a directory. It's not a guideline. It's not a catalogue. It's not something you can do if you fancy it. It's what we will be doing in the National Health Service. That's why it's called a directory. And in some of the instances, we have moved tests and changed the way we're going to use the testing strategy to improve the opportunity for patients to access the latest tests based on cost effectiveness and evidence of efficacy. And where there isn't full evidence of efficacy, but there's very positive signs, we will use our processes to evaluate those findings and then bring them live as the commissioned evidence proves their utility or not, as the case may be. So we have examined 750,000 tests routinely deployed across the National Health Service in England, and we're changing approximately 25% of those tests to be replaced by newer technologies, including whole genome sequencing. And I'm going to show you some numbers, some of which are indicative and just indicate how we're thinking about this. But the NHS is preparing to commission whole genomes 26,500 in the year 18-19, which is a half year because of financial reasons. And then in 1920 and 2021, these are just indicative numbers. They're not definitive yet because we don't have those budgets. But essentially, what I am showing you is if we concentrate the whole genomes and every other genomic test in a single national data center under the framework of consent with their treatment, lifestyle exposures, this will be the most extraordinary resource under informed consent to allow us to interrogate pharmacogenomics for the future. So those cases where we don't have certainty today, we will use these data to produce the certainty and then move them within a year on our annual test directory review into health service care directly. So we are never going to give up on this. We're going to keep going. And we now have a joint NHS Genomics England Pharmacogenomics Working Group, which Sue and I co-chair, and many of you in the room are making a fantastic contribution to this, and it's coordinated it from Alexandra Pickard with Ellen McDonough and our team at Genomics England. And so what we are doing is harnessing the talent across the nation to advise us on how to assess all the evidence for PGX. For general testing, every single test that should be used will be considered, and whole genomes. So it's not just what we might serendipitously find from a whole genome sequence, it's what the tests that should be deployed that are most efficacious, for which we have the most evidence, or we should test and gather the most evidence, will be brought live in a limited number of tests as additional findings. And so this is the work that we're doing at the moment. We've been using a scoring system based on the tried and tested and benchmarked rare disease scoring system, but adapted for PGX as a simplified scoring system. What I have to say is what we've done is we've looked at initial score sets from this, and for various reasons, which I can expand on a little bit, in the first review there were some anomalies in those tests. So we're not yet ready to share what those tests might be with anybody, because we need to rummage through those and work out why the scoring system may have thrown up a few tests that are surprising or ignored other ones which we think should be brought live. So we look at these in a variety of ways in the scoring system: the likelihood of an actionable variant or allele in that gene, level of clinical benefit. Fantastic work's been done by Keith's team, Ravi and Keith's team, to tell us about drug usage related to the test. The evidence level, focusing on guidelines, all curated by Ellie and her team and brought to the committee for their consideration and scoring. And in some cases, some of the reasons for the scoring is the absence of evidence in national or international guidelines of a utility of that test, which skews the score slightly. So we're now looking at all of these cases on a case-by-case basis, thinking about this from what genes and molecular signatures would be most beneficial to patients. And if appropriate, this will feed into the National Test Directory from April 2019 and will continue to be part of the annual review. So we will have one of the first pharmacogenomically enabled health systems in the world live from the NHS, and we will introduce these things as a part of the 2019 programme based on evidence-based testing strategy, and also testing through evaluation of edge case tests that we can't create the evidence base for now. We will also be considering how we use whole genome drug information, and this will all be concentrated in a single NHS or research data centre for you and others to work on with informed consent, and also shareable with industry. So one data centre for the whole of the nation's health repository in this respect will allow us to make the observations we can't make today because we need to capture that across a health system to find out the relevance of the test. So this is a fantastic opportunity. Thank you for having me here today. I hope you'll seize this moment and use the framework of Ellen's ask of you, the 3 points she's asked you about earlier, to make sure that we know and take away your thoughts, and Munir can bring them back to the committee with Keith and others here, and we can therefore make sure we get the best system for doing this. And if we do it here, the rest will follow. Thank you. Thank you.